Hi everyone! In this video, I'm going to go over some common math algebra mistakes which people usually tend to make. So hopefully after watching this video, you'll know what these mistakes are and you can avoid making them yourself. So let's get started. The first one I have here is actually a really cute image. So it says, every time you do this or this, a puppy dies. Now, this is something you can do. Look at how cute this puppy is. You wouldn't want it to die, right? If you don't like puppies, I don't know, think about something you like, but really, this is something that you shouldn't do. So this is basic stuff, which it's just really tempting, so people tend to make these mistakes. But hopefully after I go through this, you understand them and you will avoid making them yourself. So here it says x squared plus 3 the whole squared equals x to the 4 plus 9. So why this is wrong is because what they've done is they've just distributed the power. So they said, okay, I'm going to take x squared and raise that to the second power, and then take 3 and raise that to the second power, and that's going to give me x to the 4 plus 9. But this is wrong because, okay, so I'm just going to put that here. It says x squared plus 3 the whole squared. Now, if you look at this, then you might be able to recognize that this is actually one of the algebraic identities. This is a plus b the whole squared. So whenever I have something like that, whenever I have a plus b the whole squared, that actually gives me a squared plus 2ab plus b squared. Okay, and if I was to substitute that for this, my a is x squared. So a squared would be x squared the whole squared plus 2 times my a is a squared and my b is 3. So 2 times a squared times 3 plus my b is 3. So 3 squared. That's going to give me x to the square, x squared raised to the second is going to give me x to the fourth. Plus here 3 times 2 is 6, so 6a squared, plus 3 squared is 9. So what we actually get if we square this is x to the fourth plus 6a squared plus 9. Here you can see that what they've gotten is x to the fourth plus 9. So they're actually missing this middle term. So if you just distribute the squares like this, you are going to get it wrong. So this is incorrect. Okay, so you want to use the identity and get the entire expansion. Here, the second one, x squared plus 9, the square root of x squared plus 9 equals x plus 3. So again, what they've done is they've just taken the square root of each term individually. But this again is wrong because this is again based on the identities. Here I have x plus 3, right? X plus 3 is what they're getting, and they're saying if I take the square root of something, I should get x plus 3, which means if I square x plus 3, I should get that, correct? Because that is equal to this. The square of x plus 3 is going to give me what's inside, right? So let's see what we get if I square x plus 3. If I square x plus 3, then again we have to use the identity, a squared plus 2ab plus b squared. My a squared is x squared plus 2 times a, or x, 2x, times 3, so 6x, plus 3 squared is 9. Okay, so again, this middle term is missing. So this is not, the square root of this is not equal to this. This again is wrong. Okay, so when you see something like this, especially with two terms and you square them together, a cube or whatever, but if you see something like this, I know as tempting as it is to just distribute the squares or just square root each term separately, don't do that, it's wrong. Okay, so let's move on to the next one. Here I have a kitten. So it says every time you do this a kitten dies, and just look how cute that is. Okay, so let's see what they're actually saying here. So here we have some function f of x, or it doesn't even matter if it's a function, let's just look at this fraction here. So they have a fraction with 3 terms in the numerator, x squared plus 2x plus 1 over x squared plus 3. And what they've done is conveniently just canceled out the x squares because there's an x squared in the numerator and x squared in the denominator, and they're just left with 2x plus 1 over 3. But this is wrong. So let's see what they've done. They said x squared plus 2x plus 1 over x squared plus 3. Now, when you have a fraction and you have multiple terms in the numerator and they're being added together, what this actually means is it's x squared over x squared plus 3 plus 2x over x squared plus 3 plus 1 over x squared plus 3. So when you have 3 separate terms and they're being added together and you're dividing them by a common denominator, it means that each one of the term is being divided by the denominator. Okay? So when you're canceling out something like that, you're saying you're taking out one term of the denominator and taking out just one term of the numerator, but that's not what's happening. So if I just take this out here like they did, then I'm still left with so much of the equation, and this itself is wrong because x squared is not divided by just x squared, it's divided by x squared plus 3. So that's wrong, and that's something I can do. Now, to understand this better, let's look at a numerical example. So if I have, say, 3 plus 5 over, let's make that 6 plus 5 over 3, okay? Now, what is this? 6 plus 5 is 11 over 3. So if I'm doing this correctly, I should get 11 over 3, right? So no one disagrees with that. But if I did what they did, and I'm just going to cancel out similar terms, and I say, oh, there's a 3, and then I have 6, so 3 times 1 and 3 times 2, so that's 5 plus 2, that's 7. That is wrong, correct? So here we get 7, but that is wrong because the answer we're supposed to get is 11 over 3, but that's not what we're getting. I'm just canceling out terms, I'm left with 7. So we know immediately that this is something we can do. And when we see it in a numerical example where maybe it seems obvious, it's obvious that we won't just cancel it out. But what we're doing here is the exact same thing we're doing here. It's a numerator by denominator, and you can't just take out a term unless it's multiplication. So if I had x squared times 2x times 1 over x squared, then here, because it's multiplication, I can take out this, and that will leave me with 2x times 1, which is just 2x. But I can only do that if the terms are being multiplied with each other and not added or subtracted, okay? So this is wrong, something we should never do because we don't want kittens dying, right? Okay, so let's look at the next common error. So here I have something which a little more basic, but something which people tend to do, especially in maybe exams when you're in a hurry and you're not really tracking what you're doing. So here I have negative multiplied by something in the bracket. Now what this actually is, it's negative 1 times this. And when you have something outside and you want to multiply it out, what you have to do is this is being multiplied to each of the terms, not just one. So the common error people make is they say, oh, okay, so it's going to be, they multiply it with the first term. They say, oh, negative x, and then they just forget about the other two terms, and then they leave it as 3x minus 7. But this is wrong because what you're doing is you have to FOIL and you have to multiply it by every term and not just the first term. So this would be wrong. And the correct method would be, so negative 1 times x is negative x. Negative 1 times 3x is negative 3x. And negative 1 times negative 7 is positive 7. So this would be the correct answer. Okay, so the next thing is, so I have 2x plus 3 times x minus 1 equals 0. And when something is equal to 0, we know that either this term or this term must be equal to 0. So we can set both the terms to be equal to 0 separately and solve for x. So here we'd say 2x equals negative 3, x equals negative 3 over 2. And here I'd say x equals 1. So we get our two values for x, right? Because we're saying when two things are multiplied together to equal 0, then one of them has to be 0. But the common mistake that people do is when they see something like this, and this, instead of equaling 0, say it equaled 1, right? Then people tend to go, oh, 2x plus 3 equals 1, and x minus 1 equals 1. But this is wrong. You can only use the null factor or the zero product rule when you have something equaling to 0. Okay, because in order for something to be equal, when two things are being multiplied and if they have to equal 0, so if I have, say, 3 times x equals 0, then you automatically know that this x has to be 0, because for something to be 0, it has to be multiplied by 0, right? For something multiplied by something to equal 0, that has to be 0. So we know that, and that's why we're setting those two things equal to 0. But when you have something multiplied to equal another digit other than 0, like 1 maybe, then you can't set them equal separately to 1. That would be wrong. Okay, so you can only do this if it's equal to 0. Now the final thing here is negative 8 the whole squared. Now this equals negative 8 times negative 8, which is positive 64. Sorry, 64. But what people tend to do is they say, well, I have negative 8 squared, so that's negative, and then 8 times 8. And they say, well, 8 times 8 is 64, and just negative. And then because there's a negative, we attach the negative. So they say, well, negative 8 squared, oh, that's negative 64. But this is wrong. When you have a negative being squared, then it's that negative value times the same negative value. So when you have a negative times a negative, that has to give you a positive value. Okay, so these are some common mistakes, and hopefully now you've seen them and you know how to go about them and you won't repeat the same mistakes. Thank you for watching, and I hope that helped.